Yes, good evening and welcome to our class. In this class, we are going to look at something briefly on computer programming. And before then, let me take some few moments to check whether all of us are in class by taking the roll call. I can see we have Clinton. Confirm your presence.
Very present, sir.
Yes, that's right. We also have Dan. Are you in?
Present.
That's right. We have Bruce.
Present.
That is good. We have Pius. Right. And then we have Terer.
Present.
Yes, Terer.
Present.
Terer, I can't hear you.
Present, sir.
Yes, that is right. And then we have Kim.
I'm in, sir.
Right. So we can now proceed. So we are going to look at something on computer programming, and let us start with the basic programming concepts that we will be talking about from time to time when we are handling this unit. And the first concept is a computer program. A computer program is a series of organized instructions that directs a computer to perform a specific task. We normally say without computer interact with the users. We also have programming, and programming is the creation of this set of commands or instructions directs a computer in carrying out a task. We have programming language, which is a set of words, symbols, and codes that enables humans to communicate with computers. What are some of the examples of programming languages that you know? What are some of the examples? Views, give us an example of a programming language.
Pascal.
Yes, that is right, Pascal. And then Dan, give us another example. Which programming language do you know?
We have Visual Basic.
Visual Basic is right. Terer, give us an example.
C#.
C#, huh? Yes, that is right. Those are some of the examples of programming languages that exist. There are very many of them. Let us proceed to structured programming. And structured programming is a subset of procedural programming that enforces a logical structure on the program being written to make it more efficient and easy to understand. We have some languages that use a structured way when they are being implemented. Some of them including Pascal. We also have C and C++. When we are programming, there is a flow or an hierarchy that we normally follow. And an example of a programming language like C is structured programming that follows such an hierarchy, where when we have a problem, we first break it down into smaller modules, which we normally refer to as functions and procedures, and attempt to simplify or solve them from there so that we can build or come up with a system. let us look at a brief history on programming languages. And the first programming language that was developed is what we call the machine language. The machine language is actually the programming language which was next to the machine. When we say next to the machine, we mean that it was best understood. And yes, someone, you have to mute your mic. Yes, can you hear me? Are we still together? Dan, are we still together?
Yes, yes.
Yes, that's right. So we can proceed. And I was talking about the machine language as the first programming language that was designed. We look at the machine language, it was written in binary digits, the zeros and the ones, and it was only understood by the machine. Then we have the second generation, which involved the development of the assembly language. And assembly language was more friendly and in human readable notation. The assembly language wrote instructions using simple codes that are meaningful and that involve meaningful abbreviations or what we call mnemonics. Then the third generation programming language, or what we call the procedural languages, which uses series of English-like words that are closer to the human language. The examples of these are the Pascal, the Fortran, the BASIC. We also even have the C. The fourth generation languages were high-level programming languages that were sometimes, normally referred to them as the call-oriented programming language because they are very specific and they have a particular syntax that we follow when we are using them. The fifth generation programming languages are what we call the visual programming languages, which are normally executable in a visual programming environment. Let us look at some of the programming paradigms that we will be using from time to time. And when we talk about a paradigm, we are referring to a style or some way of programming. Some languages make it easy to write in some paradigms, but not others. Some of the paradigms that we need to understand are a class, and a class is a collection of similar objects. And when we talk about objects, we are referring to members of a class. Then when we talk about structure, we are talking about programs that have clean, code-free, and nested control structures. Then we have procedural, imperative programming with procedural calls. We have functional or applicative, where computation proceeds by nested function calls that avoid any local state. Then we have function level, where programs have no variables. Then we have object-oriented programming, where computation is effected by sending messages to objects. And some of the terms that we normally use in object-oriented include abstraction, inheritance, polymorphism, and encapsulation. Let us go to program design and development. And program development in computing refers to the coding of an individual software program or to the creation of an entire information system and all the related software. Program design is the activity of progressing from a specification of some required program to a description of the program itself. It refers to the process that organizations use to develop a program. So we can talk of a program design as a plan of action that results from the process of programming. We have the programming development lifecycle, which begins with what we call the ideation. Ideation is the coming up of an idea so that you can develop a system based on that idea. Then we have the requirements, where you collect and the form of what you need when you'll be writing your program. Then we have design, which involves creating the architecture of a software system and some of the elements. And then you go to development. After design, you can now build your system by coding. And after you are done coding, you can now test to evaluate the quality of the system that you have managed to come up with. After testing, we have the deployment, where you prepare the software to run and operate in a specific environment to make sure that it is effectively working. And then finally, we have maintenance, where you keep on updating and supporting the software after it has been delivered to the market or the users. So those are some of the steps that you follow when you are coming up with a system. And those are some of the things that we wanted to look at in this very brief session. Unless there is a question, from members, let me ask one of you what normally happens during the program testing. Dan, what do you think normally happens during the testing of a program?
The stage of testing a program, this is where we test for errors in a program. Then we try to debug them.
Yes, that is very right. During the testing, we locate and remove errors if there are any, and then to make sure that the system is set and working right. We will stop from that point, and I'm going to send an assignment based on what we have done today. So we'll call it a session, and have a good evening. Thank you.